On the morning of June 9, 2026, tourists walking along the Promenade des Anglais in Nice, one of the most photographed beachfronts in the world, began noticing something new. Signs, blue and white, installed at regular intervals along the 7-kilometer promenade and throughout the city. They carried a wave symbol and an arrow pointing inland. They read, "Tsunami Evacuation Zone." Reporters who spoke to visitors on the beach found that most of them had no idea what the signs meant or why they were there. What the signs are actually responding to is a formal warning from UNESCO. The United Nations organization responsible for global tsunami preparedness has stated, based on decades of seismic and oceanographic data, that there is a 100% chance of a tsunami of at least 1 meter striking somewhere in the Mediterranean within the next 30 to 50 years. Not a possibility, not a risk, a statistical certainty. And in some of the scenarios scientists are most concerned about, the first wave would reach Nice in under 10 minutes. The alert system that France operates is not fast enough to help in those cases. The signs are the plan. This is the story of why they are there, what the Mediterranean's geological record says about the threat they are pointing at, and what 87,000 people on a beach have 10 minutes to do. The Mediterranean is not commonly thought of as a tsunami-generating ocean. It is smaller, calmer-seeming, enclosed. The image does not fit the threat. The image is wrong. After the Pacific, the Mediterranean basin holds the highest number of historically recorded tsunamis of any body of water on Earth. Since 1840, approximately 10% of all documented tsunami events worldwide have occurred in the Mediterranean. The French Riviera alone has recorded approximately 20 tsunami incidents between the 16th century and the early 2000s, with waves that often exceeded 2 meters. The sea has been doing this, quietly and without much international attention, for as long as human settlements have occupied these coasts. The reason the Mediterranean produces tsunamis is geological. The basin sits at the convergence of the African and Eurasian plates, creating a seismic environment far more complex than its reputation suggests. The Calabrian Arc in southern Italy and Sicily is one of the most seismically active regions in all of Europe. The Algerian coastal margin, running along North Africa's Mediterranean edge, hosts active fault systems capable of generating significant offshore earthquakes. The Ligurian Sea, the body of water between France, Monaco, and the Italian Riviera, sits above unstable underwater sediment deposits on steep submarine slopes. And several active volcanic systems across the Mediterranean floor, including Stromboli and Santorini, have produced tsunamis of their own. Each of these sources generates a different kind of tsunami with a different warning window. That distinction is the core of what scientists working on the Nice project are trying to communicate, because the warning time is not uniform, and in the scenario they worry about most, there is essentially no warning time at all. On the morning of October 16, 1979, construction workers were building the new commercial port adjacent to the Nice Côte d'Azur airport, on land reclaimed from the sea just west of the Promenade des Anglais. Part of the underwater slope below the construction site destabilized and collapsed. There was no earthquake. There was no warning. The seafloor material that slid into deeper water displaced enough water to generate a tsunami that struck the coastline within minutes. 8 people were killed. Significant damage was reported in Nice, Antibes, and Cannes. The wave was observed in Antibes for approximately 30 minutes. This was not a historically exceptional event. It was a medium-sized version of a class of hazard the French Riviera has experienced repeatedly. In 1887, an underwater earthquake measuring between 6.5 and 6.8 in the Ligurian Sea produced a tsunami that caused the sea to retreat approximately 1 meter off the beaches of Antibes and Cannes, leaving fishing boats stranded on wet sand, before a wave of nearly 2 meters arrived and washed across them. In 2003, a magnitude 6.8 earthquake beneath the seabed off the Algerian city of Boumerdès sent a tsunami toward the French coast. The wave arrived approximately 75 minutes after the earthquake. It caused sea level drops of between 50 centimeters and 1.5 meters in 8 marinas along the Riviera, produced violent currents inside harbors, and caused significant damage to boats. No one died in France from that event, but the marinas experienced a force that, on a beach with tens of thousands of people, would have been something entirely different. Here is why the 10-minute figure is not an exaggeration. The same submarine slope instability that caused the 1979 event represents an ongoing trigger. The Ligurian Sea is not large, and the distance between an unstable slope and the Promenade des Anglais is short. In simulation models run by researchers at the University of Montpellier, certain local submarine landslide scenarios produce waves that reach the Nice waterfront in fewer than 10 minutes. A distant earthquake from North Africa, like the 2003 event, would give between 75 and 90 minutes of travel time. A local event in the Ligurian Sea would not. France operates a national tsunami alert system called CENALT, active since 2012 and integrated with UNESCO's International Monitoring Network, that can issue a warning in under 15 minutes. That capability is effective for distant tsunamis. For the local scenarios scientists are most focused on, where the wave arrives before the alert cycle completes, the system is not designed to help. In the fastest scenarios, warning systems are not enough on their own. Evacuation planning and public awareness are the only tools that work. This is why 800 signs now stand along the Promenade des Anglais and throughout Nice. The promenade is 7 kilometers long. At peak summer capacity, July and August, when Nice hosts millions of visitors from across Europe and beyond, the beach and promenade area holds up to 87,000 people simultaneously. They are concentrated at or below sea level, on a narrow strip of waterfront backed by dense urban development. The nearest elevated ground is not a beach away. It is a walk through city streets, uphill, past parked cars and sidewalk cafes and intersections. The University of Montpellier team has mapped nearly 100 refuge sites across Nice, with optimized evacuation routes published on an online platform that residents and tourists can consult in advance. The practical question, the one that the 10-minute scenario makes brutally concrete, is how many of the 87,000 people on the beach on a given summer afternoon have looked at that platform, know what the blue evacuation signs mean, know which route to take, and know that the correct response to an unusual retreat of the sea is not to walk toward it to look at the exposed seabed, but to run in the opposite direction immediately. Japan's experience from the 2011 Tohoku earthquake provides the clearest data on how much preparation matters. In communities along the Tohoku coast that had invested in preparedness, elevated escape routes, public drills, clear signage, survival rates reached approximately 96%. That infrastructure built over decades was the difference. Nice installed its first tsunami signs in February 2026. The 800 signs along the promenade were installed in June. The city is working toward certification under UNESCO's Tsunami Ready program. Cannes already has the certification, Nice is following. The first signs have been there for 4 months. The tourist on the beach who arrived last week has had 0 days. The Mediterranean's historical record offers no comfort about the scale of what the geology here is capable of. In December 1908, a magnitude 7.1 earthquake in the Strait of Messina between Sicily and mainland Italy generated a tsunami with waves reaching 12 meters in some coastal areas. The combined earthquake and tsunami killed an estimated 200,000 people, one of the deadliest natural disasters in European history. Those were different eras. But the faults have not closed, and the Ligurian Sea slopes have not stabilized. UNESCO is currently coordinating the Nîmes Wave 26 exercise, a multi-country tsunami preparedness drill across the northeastern Atlantic, Mediterranean, and connected seas region, running scenarios based on historical events including the 1887 Ligurian Sea quake and the 1755 Lisbon earthquake. The scenarios are not hypothetical. They are recreations of things that have already happened. There are 3 signals scientists and civil protection officials are tracking. The first is the pace of public adoption. Nice has the signs, the evacuation maps, and the refuge sites. Whether 87,000 summer visitors, many of them non-French speakers encountering the signage for the first time, can translate that infrastructure into effective behavior in a 10-minute window is an open behavioral question that no model fully answers. The second is the expansion of Tsunami Ready certification across the region. Spain, Italy, Greece, and Algeria all have exposed Mediterranean coastlines with comparable or greater vulnerability. The degree to which the preparedness framework being built in Nice spreads to other resort cities along the arc from Barcelona to Athens will determine whether the next event finds a population that knows what the signs mean. The third is the monitoring of the Ligurian seafloor itself. Submarine landslide hazard modeling depends on data about sediment distribution, slope angles, and accumulation rates that is updated infrequently. The 1979 event occurred on a slope that had not been flagged as an imminent hazard. The tools to identify the next unstable slope before it moves are improving, but they are not yet comprehensive. UNESCO has been explicit. The question is not whether a tsunami will strike the Mediterranean within the next 30 to 50 years. The question is only where and when. For Nice, with 800 new signs pointing toward refuge sites that most visitors will never look up, the answer to whether those 2 variables will be favorable when it happens depends almost entirely on how seriously the next decade of preparation is taken. The signs are up, the routes are mapped, the wave has not arrived yet. In the Mediterranean, those 2 facts have always eventually stopped being true at the same time. Subscribe to stay ahead of what's coming.